continue on here with this example. We're going to establish the identity. So what we're going to do is we're going to expand that cosine alpha minus beta into cosine alpha, cosine beta plus sine alpha, sine beta. Let me just show you right here. So we're going to work with this left-hand side and then show that it's equal to the right. So again, we expand that. There it is. And leave it over sine alpha, sine beta. Now this is a common denominator of both of those two. So go ahead and split it up into this one plus that one. Now notice this right here is 1. That's where you get the 1. And over here you got cosine over sine. So there's cotangent alpha. There's cotangent beta. And there you go. That's what we were trying to show. Not too bad. Here's some sum and difference formulas for the tangent function. And we'll establish an identity with that as well. So we'll have tangent of theta plus tangent pi. So tangent theta, tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. And we're going to show that that's equal to tangent theta. Now remember, tangent theta, or I'm sorry, tangent pi is sine at 180 degrees over cosine 180 degrees. Well, we know sine there is 0, cosine is -1, so this just ends up being 0. So this is tangent theta plus 0 over 1 minus tangent theta times 0, which means that's gone. So you're just left with tangent theta over 1. So tangent theta equals tangent theta. Done. Alright, tangent theta plus pi halves. Now, if I was to use that same tangent alpha, so tangent theta plus tangent pi halves over 1 minus tangent alpha tangent beta, to show it's equal to negative cotangent. The problem is it doesn't work because tangent pi halves, that's sine of pi halves over cosine pi halves. Well, the sine of pi halves is 1, cosine pi halves 0. This is undefined. So this is undefined, so I don't want to use that in doing this problem, okay? So what I'm going to do instead is I'm just going to say, you know what, I'll just keep going here. I'm going to use the fact that the tangent's the sine over the cosine, right? And then I'm going to expand sine alpha plus beta, and then I'm going to expand cosine alpha plus theta. So there they are expanded. And then I fill in, I say, well, cosine of pi halves is 0, sine of pi halves is 1, cosine pi halves 0, sine pi halves 1. So it looks like that's gone, and that's gone. So I've got cosine over negative sine, which is just negative cotangent theta. That's what we're trying to show anyways, to establish that identity there. All right, example 9 here. What I'm going to do on this first is I'm going to say, I'm going to make this, I'm going to call this alpha, I'm going to call that beta, so I'm going to say the arc cosine of a half equals alpha. And I'm also going to, number 2, I'm going to take the arc sine of 3/5, I'm going to call that beta for a minute. You know, it's kind of like we used to just call it theta, but I need these to be two different angles here, so I'm going to call alpha and beta. Well, if the arc cosine of a half equals theta, that means the cosine of alpha is a half, right? Cosine of alpha is a half, where alpha then, because this is the arc cosine, is between pi and 0. And then over here I have the arc sine of 3/5 is beta, which means the sine of beta is 3/5, where beta is between negative pi halves and pi halves. So let's draw a picture of this. Alpha, I have a cosine that's positive, and it's between 0 and pi. Well, if my cosine is positive, that's got to be my angle alpha. And cosine is adjacent over hypotenuse, 1 over 2. So I'm going to go ahead, use the Pythagorean theorem, solve for my remaining side. So 1 squared plus b squared equals 2 squared. Solve for that. Gives you root 3. Over here on my beta, I say this is between negative pi halves and pi halves, and my sine's positive, right? It's between here or here, but my sine's positive, so it's got to be Beta's got to be up here. Sine is opposite over hypotenuse. Solve for the remaining side. A squared plus b squared equals c squared, so that's got to be 4. And then our third step, number 3. This is sine, remember we called this alpha and this beta. So this is really sine alpha plus beta, which is sine alpha cosine beta plus cosine alpha sine beta. And now we can answer all our questions. Sine of alpha, so now I'm looking over here at alpha. Sine of alpha opposite, here's the opposite side. Here's the hypotenuse, root 3 over 2. My cosine of beta adjacent, so now I'm looking over here at beta, adjacent over hypotenuse, 4/5. And then cosine alpha, I'm back over here to alpha, adjacent, so 1/2 over hypotenuse. Sine beta, I'm back over here to beta, opposite over hypotenuse, 3/5. So I got, this becomes 4 root 3 over 10, 4 root 3 over 10 plus 3. So 4 root 3 plus 3 all over 10 is the exact value of that right there. Okay. All right, how about solve the equation here? Sine theta plus cosine theta equals 1. One way to approach this is if you square both sides. Okay, so if I square both sides, now I got to remember if I do this, if I square both sides of an equation, for example, let's say I had x equals -1. I know that's already solved for, but if I square both sides, I got to remember that when I then go to solve it, I got to check both. So I got to check for extraneous solutions that appear to be solutions, but they don't satisfy the original equation. Well, the original equation was x equaling x being -1, so only the -1 works, right? The 1 does not work. -1 equals -1, not 1. So again, if I square both sides, you must check for extraneous solutions, okay? All right, so we square both sides. I'm going to FOIL this. Excuse me. Now notice sine squared plus cosine squared. So I got 1 plus 2 sine theta cosine theta equals 1, right? And then I'm going to subtract 1 both sides. So I got 2 sine theta cosine theta equals 0, divided by 2, divided by 2. So sine theta cosine theta equals 0. So I could have sine theta being 0, cosine theta being 0. So theta could be, we know the sine of 0 is 0. We know the sine of pi is 0. I know sine of 2 pi, and this keeps going, but that's too big. Remember, it's got to be less than 2 pi, greater than or equal to 0. I know that theta over here, cosine, I know pi halves. I know cosine 3 pi halves is also 0. I could keep going, but the rest are bigger than 2 pi. But I said I got to check this for extraneous solutions. So again, plug it. So I got to check: does 0 work? Does pi halves work? All right. So I check each one of these. Okay. Check theta equals 0, and I'm like, okay, that works. I'm gonna check, and I'll throw this one in because I know pi doesn't work. So I check pi. Does the sine of theta plus cosine theta equal 1 when theta is pi? Does the sine of pi plus the cosine of pi equal 1? Well, the sine of pi is 0, but the cosine of pi is -1. That's not true. -1 does not equal 1. So pi is out, right? So pi was an extraneous solution. Pi didn't work. That was extraneous. You could also check the 3 pi halves. That's going to be extraneous. The only ones that work are 0 and pi halves. If you check them. Okay? Thank you so much for listening. You guys have a wonderful day.